The next type of factorizing is called the sum or the difference of cubes. Now before I start to factorize, I want to take a look at an expression that is in fact already fully factorized. What I'm going to do over here is I'm going to multiply out these brackets. In other words, I'm going to reduce them to terms. When I do that, I take the first term of the first bracket and I multiply it by every term in the second bracket. If I do this, I'm going to get x cubed plus 2x squared plus 4x. Now I'm going to do exactly the same, but with the second term of the first bracket, and it now needs to be multiplied by every term in the second bracket. When I do this, I get minus 2x squared minus 4x and then minus 8. Let's check and see what will happen when I add like terms. Well, when I add plus 2x squared and minus 2x squared, they add up to 0. And likewise, plus 4x and minus 4x also add up to 0. So once I've simplified these terms, I end up with only two terms, x cubed minus 8. So how do I get from x cubed minus 8 if I want to factorize it so I can get two bracket factors like I had in my original expression? I'm going to show you how. If you remember the introduction I gave you, I started with two brackets. The first bracket was linear and had only two terms, and the second bracket was quadratic and had three terms. If I want to factorize this expression as shown in number 1, I need to first create a linear factor. Now that one's easy because I take the cubed root of x cubed, and that is going to be x, keep the sign, and the cubed root of y cubed, and that is y. Now in order for me to get the second bracket, which had three terms and quadratic terms in it because there were x squared terms or y squared terms, I'm going to use the bracket factor that I have just created. Take a look at this. Take the first term x and square it. Change your sign. As the sign was a minus, you must write a plus. Find the product of the two terms. Well, x times y is xy. For the last term, it is always a plus. And now square the last term, y squared is y squared. Let's try this with the second example. The only difference between the first and the second examples you can see is that the first one had a minus between the two terms. That would have been the difference of cubes. The second has a plus between the two terms, so that is the sum of cubes. Now going back to the method that I had before, I find the cubed root of x cubed, x, keep the sign, the cubed root of y cubed, y. Now to get my second bracket, I use the linear bracket I have just found. Square the first, x squared. Change the sign. I had a plus, so I must have a minus. Product of the two, x times y is xy. Always a plus. Square the last. So it's actually just a little rhyme that you need to remember. Find the cubed root of each term to get your first bracket, keeping the original sign. Get your second bracket from your first bracket factor by squaring the first, changing the sign, product of the two, always a plus, square the last. Let's practice our skill in this example. If I practice my skill here, I've got quite a lot of factors, both in the first and the second term. So I'm going to deal with them one at a time. Now if I have to find the cubed root, because it's the difference of cubes, I've got to take the cubed root of 8. And that's actually the cubed root of 2 cubed, so that is 2. The cubed root of x cubed is x. Keep your sign. The cubed root of 27, which in fact is 3 cubed, is 3, and the cubed root of y cubed is y. Now that I've got my first bracket, my second one should be easy. Square the first. Well, that means square every single factor in the first term. Change your sign. I had a minus, so I must have a plus. Find the product of the two. As I've got number factors and variable factors, I have to find the product of the numbers and then the variables. Well, 2 times 3 is 6, and then I have x times y. The last term is always a plus, and now squaring 3y, I get the 3 squared, which is 9, and y squared. Here is one more example. So I have recognized that this is perfect cubes, and so I'm going to factorize using the sum of cubes. Get your first bracket from the original. The cubed root of 64 is going to be 4. The cubed root of x cubed is x. Keep the sign. The cubed root of 1 is 1, because 1 times 1 times 1 gives me 1. Now working from this bracket, move on to your next bracket. Square the first. Well, 4 squared is 16, and then I have x squared. Change your sign. Find the product of the two. 4x times by 1 is still 4x. Always a plus, and when I square 1, I get 1. I have now successfully gone from terms to factors because the sign between these brackets is a times.